Morning Silent Springs High School.
Okay. Maybe. All right. So this is on page 69. On page 70, we're going to do the vertical book. 71 will be the horizontal book. And this is Moving the Monster. Okay, and the book that you need right now is this one with the box. Okay, if you have the wrong book, you're going to be very confused here in just a minute. So make sure you get the one with the box. Just the one box. Are we all in the right book? All right. So this unit is called Moving the Monster. And so we're going to take this monster right here and we're going to move it around. All right. So we have this ugly graph. Here is our table of values. They've made it for us. Isn't that nice? Doesn't that look like a fun graph? No, that's why we call it the monster, because it's a little monstrous. But it's all right. We're going to make it through. Okay? So we're going to do this first one together, and then I'll let you work with a neighbor on some of these. So it says, complete the table and sketch the graphs and describe what happens to your original monster after each transformation. Okay? So our first one, we have y equals f of x and then plus 2. So we're going to take each f of x value from this point in the table, and we're going to add 2 to each one of these numbers. Okay, so I'm going to take the table, I'm going to take each of these numbers, and I'm going to add 2. So what's 3 plus 2? What's 0 plus 2? Negative 3 plus 2? 0 plus 2? 3 plus 2? 1 plus 2? 2 plus 2 is 4. 0 plus 2 is 2. And negative 2 plus 2 is 0. Okay, so I did exactly what this right here says. I added 2 to each y value, or f of x value. Now, I'm done with this middle column. Totally done with it. So we're going to mark it out. And now, I'm going to use these x, y points, and I'm going to plot them. So now I have the point negative 4, 5. I have the point negative 3, 2. 0 plus 2. That's what they gave us right here. It's the original problem. Okay, and then I'm just going to make each one of these into a coordinate pair. So the point 2, negative 1, and so on. That's a negative 2, by the way. Didn't copy well. Okay, so there's all my ordered pairs. And now I'm going to plot them. So on this graph, we're going to plot each of these points. So the point negative 4, 5. Negative 3, 2. Negative 2, negative 1. Once you get all of your points plotted, you're going to connect them. And it should still look mostly like the monster that we had on the front page of your book. Okay, now what happened between our original monster and this one right here after we added 2? It went up 2. We moved the whole monster and it shifted 2 units up, right? So the graph is translated 2 units up. So our original function on the front of our page, all that happened when we added 2 was we took the whole thing, we moved it up 2, right? Okay, so now I want you to do the exact same process with number 2 right here, except this time you're not adding 2. What are you doing? Subtracting 2. So with each one of these y values, you're going to subtract 2. Once you've filled out this column, you're going to cross out the middle column, and then you're going to plot your new points and see what happens between your original graph and your new one. Okay, so what happened this time? Yep, my original one on the front of the book got shifted down 2 units. So it's translated 2 units down. Okay, so when I add a number to the end, it moves my graph up 2. When I subtract a number from the end, or subtract 2 from the end, it moves it down 2. All right, so let's look at this one. Number 3, y equals 2 times f of x. We know that it's times because when there's a number right next to a letter, that means multiplication, right? So now this time, instead of adding and subtracting from the y values, I'm going to multiply them by 2. So 3 times 2, 6. 0 times 2 is 0. Negative 3 times 2 is negative 6. 0 times 2 is 0. 3 times 2 is 6. 1 times 2 is 2. 2 times 2 is 4. 0 times 2 is 0. Negative 2 times 2 is negative 4. Okay, now I'm done with that middle column. I'm going to plot my new points. You don't have to write them out as ordered pairs if you don't want to. Okay, what happened that time? It looks different. It didn't just move up or down. What happened to it? It's like stretched, right? We took it and we stretched it from top to bottom. So it's a vertical stretch by a factor of 2, or just by 2. Okay, go ahead and do that next one if you haven't already. Okay, what happened this time? Or do you need some more time? Did you have decimals this time? Oh no. No decimals? I hope you had decimals. Turn to mini. Okay, it's like we took our original one and we kind of smashed it, right, from top to bottom. Okay, instead of using the word smashed, because that's not really mathematically correct, we're going to use the word compressed. So the graph is vertically compressed by a factor of 1/2. Because we took it and we made it half as tall. So even though it was a little bit weird, just got a little bit smushed, right? Okay. Okay, so we've done some of this before. Does anybody remember what a negative in front does to your graph? It flips it, usually. Okay, so let's see if that's what happens here. So take each of your y values and multiply them by -1. And see if it flips it. Were we correct? Did it flip over? Yep. So it is reflected. We're using our math specific terms. It's reflected over what? Over the x-axis. Okay, so this next one is weird. So we're going to do it together. So we have those bars. What do those bars mean? Right here. Yep, absolute value. What does absolute value mean? Or what is absolute value? How far you are from 0. So it's talking about your distance from 0. And is your distance ever going to be negative? So basically, absolute value is always going to take your number and make it positive, right? So we're going to take all of these y values, and if they're negative, we're going to make them positive. And if they're positive, they're going to stay. All right? So the absolute value of 3 is 3. Absolute value of 0 is 0. Absolute value of -3 is 3. Absolute value of 0 is 0. 3, +1, +2, 0. The absolute value of -2 is +2. So all I did was make all of those y values positive instead of negative. So go ahead and plot those points. that still look like our monster? Not really. We took it and we changed it a whole lot, didn't we? Okay. So what happened here was all the negative y values reflected over the x-axis. So the main point here is just that when there's an absolute value involved, some weird things happen, and it does not look like your monster anymore. Okay? What? Why not? It's rude. Oh, that's awesome. Okay. So all of these things, we've done all of these graphs so far to prove to you that it does not matter what your graph looks like. There are some specific rules that can apply no matter what graph you have, and we will use these rules all year long. Every time we graph something from here on out, we are going to use these rules. So they're really important. So you really want to make sure you understand them. Okay, so we're going to make a little summary cheat sheet page. Okay. So what happened to our graph when we added a number to the end? Yep, it moved up h units. So no matter what that h is, if you add it to the end, it's going to move up that many units. What about the minus h? Down h units. Okay, when we multiplied by a number bigger than 1 in front. Vertical stretch. So vertical stretch by a. Okay, what about when a is a fraction between 0 and 1? Yep, vertical compression. Remember that a is going to be a fraction. Okay, what happened when there was a negative in front? It flips, but what's our math words we're using? Reflected over what? Yep. Reflect over x-axis. And then our absolute value reflects negative y values over the x-axis. Okay, so that's all your vertical transformations. That's up and down, right? Vertical is up and down. Those are very straightforward. Whatever it looks like, if it's a plus h, it's going to go up. If it's minus h, it's going to go down. Okay, the vertical ones are very straightforward. Exactly what it looks like is what you think it's going to be. So let's see if that's what happens with the horizontal. So now you're going to grab the next book that has the same front, but it does not have the box. What? You're about to panic? Don't panic. Okay, so that book, that first book was on page 70. This book is on page 71. Tape. Okay, So we're going to take our same monster, and we're going to do some other things to it. All right. So this time I have another +2. But why is this one different? Where is the +2 this time? It's next to the x. It's on the inside of those parentheses, right? So now my table looks a little bit different. I need to find my x value when they give me what x +2 looks like. So what number +2 is -4? -6. What number +2 is -3? What? -5. What number +2 is -2? -4. And then -3, -2, -1, 0, 1, and 2. Because 2 + 2 would give you 4, 1 + 2 would give you 3, 0 + 2 would give you 2, blah, 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 right? So just like last time, once we've used this middle column, we're going to mark it out. And we're going to plot those points. What happened this time from our original one? Nobody knows what direction that is? Went to the left, right? We took our original monster and all of those points went to the left too. So the graph is translated left 2 units. Or 2 units left, I guess you could say. I know, it's backwards. That's going to bother me. Two units to the left. So this time we added 2, but it went to the left, which is kind of the opposite of what you would think, right? So what do you think is going to happen when I subtract 2? It's going to move to the right. So if you want, you can complete the table, but you don't have to. You can just take each one of these points and move them 2 units to the right. The table is just there to help you figure that out, but you guys already know that. You can assume that that's what's going to happen. Okay, so go ahead and plot your new points here. Okay, when you plotted your points, did they move? Did all of the original points move to the right 2 units? They should have. Okay? So even though we subtracted 2 from the inside, and you would assume, or you would think, logically, it would go left 2, it actually went to the right 2. Okay, so just keep that in mind. Let's do the next page. Okay, so number 3, we have y equals f of 2x. So that means 2 times x equals these numbers right here in the middle. So 2 times what gives you negative 4? Negative 2. 2 times what gives you negative 3? Or what's negative 3 divided by 2? How about that? Negative 1.5. 2 times what gives you negative 2? Negative 1. 2 times negative 0.5 is negative 1. 0 divided by 2 is 0, and so on. Okay, then mark out your middle column and plot your points. Okay, what happened this time? It got smashed, right? Which direction? Side to side, right? We took it and horizontally smashed it. But what's the math word we use for smashed? Compressed. So the graph is horizontally compressed by a factor of 1/2, not by a factor of 2. Okay? Anytime you use the word compressed, you're going to have a fraction or a decimal. Okay, compressed means you're going to have a fraction. Okay, so try the next one. What do you think is going to happen on the next one? Horizontal stretch, probably. Okay, but go ahead and fill out your table. And if the table is confusing, it's asking you half of what number is negative 4. Wouldn't that be negative 8? Making you think a whole lot this morning, sorry. Okay, so that's what it should look like. Horizontally stretched by 2, not by 1/2. Okay, on the next one, I want you to do the one at the top, not the absolute value one. So I want you to do number 5, but not number 6. We are not going to do number 6. Go ahead. Do number 5 when you get finished. Check it with your neighbor. Okay. What happened that time? It reflected over what? The y-axis. All right. We're not doing this absolute value one. So let's go ahead and flip to that last page. All right. And this one is the most important one we'll do of the day. It's also the last thing we're going to do today. Then you'll have lots of time for homework. It's nice. Yeah. Time to work on your homework is nice. Homework's not necessarily nice, right? Huh? I know, we're not going to. It won't show up again. It won't. Okay. So we're going to start with the ones we just did. Whenever we added 2 on the inside, what happened? Flip back and look. When we added 2 on the inside, went to the left 2. Whenever we subtracted 2 on the inside, what happened? Went the other direction, it went to the right 2. What about when we added 2 on the outside? Nope. Huh? It went up 2. And when we subtracted 2 on the outside, down 2. Okay, when we multiplied by 2 on the inside. Hey, Mr. White. Okay, we're almost done. Okay, what about when we multiplied by 2 on the inside? You're showing me with your hands. It was a horizontal squish, right? A horizontal compression. By a half. And then what happened when there was a 1/2 on the inside? Horizontal stretch. By 2. Okay, what about that 2 in the front? Yep, that was vertical. So that's a vertical stretch by 2, which means the 1/2 was a vertical compression. Anytime you use the word compression, you have the word, or a fraction, sorry. What did the negative on the inside do? Reflect over the y-axis. And the negative on the outside reflected over the x-axis. Yeah, Micah is carrying you. You guys owe him like some Skittles or something. Okay. And then on this absolute value one, it's the same thing we put in that last box on the other summary page, where all the negative y values reflect over the x-axis.